Hello viewers, I hope all of you are fine. Today I want to discuss another very basic and fundamental topic related to classical mechanics, and that is basically the Newton's second law representation in terms of linear momentum. So before this topic, let's discuss a little bit what is basically momentum. You know very well that basically momentum is the product of mass and velocity, or in other words, you know that basically momentum is the quantity of motion in a body is called momentum. So let's first understand this. What is mean by this? Basically, we know that momentum is the product of mass and velocity, so that's why let's discuss whenever two objects having the same velocities and of different masses comes uh, towards us, then we know that basically the heavier one mass will be very difficult to stop that compared to the lighter one body. So it means that basically the heavier one mass will be of greater momentum, because greater quantity of motion is basically consist by that heavier mass. Similarly, let's suppose two objects having same masses and of different velocities come towards us, and we know that the that object which having the greatest velocity compared to the other body will possesses the greater momentum, because consists of greater quantity of motion in that body, because we know that basically momentum is a product of mass and velocity. So if either mass is greater or if velocity is greater, then the momentum will be greater. So that's why we understand momentum like this. So now let's discuss how we can relate Newton's second law, which is basically F is equal to ma, with momentum. So we know that basically F is equal to ma. This is the Newton's second law mathematical form. This is basically acceleration, which is a vector quantity, mass is a scalar quantity, force is a vector quantity, but we know that acceleration is the rate of change of velocity. So if we replace acceleration with the rate of change of velocity in equation 1, then this equation becomes like this. And then we know that basically mass is a scalar, so this is already another rule that we can easily multiply scalar quantity with a vector quantity. So we can write this equation like this. So this is another form of this equation. Now we know that when m is multiplied with v, then it becomes momentum, because this is the definition of momentum, that momentum is the product of mass and velocity. So now this is almost our final result. By replacing mv with p, which is basically momentum, this equation becomes like this. So now if we compare this equation with this equation, then we see that basically force F is equal to ma, which is basically Newton's second law, or similarly force is equal to del p by del t, which is also a Newton's second law, but this is in terms of mass and acceleration, Newton's second law, and this one is basically in terms of momentum. So this final result tells us that basically the rate of change of momentum is equal to the applied force, and this one equation is basically tell us that basically the product of mass and acceleration is equal to the applied force. So these are basically the two different forms of the Newton's second law. This one is called the Newton's second law in terms of momentum. So I hope you learn a very basic idea, or got a very basic idea about how we can express Newton's second law in terms of momentum. Thanks for your time. Subscribe this channel for upcoming interesting videos. So I hope you like this. Thanks once again.